All right, today we are doing section 10.7, which seems strange since we've been in the middle of chapter 8, but it does use a lot of our chapter 8 knowledge, so we're going to jump on in. Our objective is to graph linear inequalities in two variables. So instead of just graphing equations, we are graphing inequalities. All right, to warm up, we are going to graph linear equations. So this is what we've done before. They're in slope-intercept form, so we just have to graph our y-intercept and then use our slope to get more points. Y equals mx plus b. So if it helps, you can start off by identifying your m and your b. Who can help me identify those on number 1? Kian? M is 2, B is 3. Usually we like to write our slope as a fraction, so I would put 2 over 1. B represents our y-intercept, so we start off on our y-axis, which is the vertical axis, and we go up 3 and put a point. That's what it means for B to equal 3. Then we use our slope as rise over run. So from that initial point, we are going to rise how many? 2, and run 1. If it's a positive 1, which way do we go? To the right. So we go up 2, right 1. Up 2, right 1. Up 2, right 1. Instead of going up and to the right, where could I go? Down and to the left. So down into the left, down into the left, and we can keep on doing that as many times as we want. The more points we have, the better. Then we just need to use a straight edge as best we can through those points. Make it go all the way through the graph. That'll be super important today as well. Technically, I should extend that to go all the way through. Put the arrows on the ends. So this should be review. We have done this before. We've been tested on this before, but this is a skill that we have to have in order to do today's lesson. On the second one, who can tell me my M and my B? Jaquan? Very good. M is negative 1/2, B is negative 2. We start with our B, so we go on our y-axis. We go to negative 2, so that's down 2 from the origin. We put our point. Our slope is negative 1 over 2. So who can tell me where to go with that slope? Surely somebody. Ellie. We've only got one negative sign. So if we go down, we would have to go to the right. Down 1, right 2. Down 1, right 2. Or who could tell me the other option? May? Up 1, left 2. We can reverse both of those directions and we will still be on the same line. And we just need to use a straight edge to get our line going through that graph. That's not perfect. Let's see. That's not perfect, but it's better. There we go. We've got those lines graphed. All right, today we are going to talk about linear inequalities. So here it says when we graph linear equations, we have 3 sets of points. The points on the line, the points above the line, and the points below the line. Separate them into 3 categories. A little more vocab. The regions above and below the line are called open half planes. The line is the boundary of each half plane. Graphing inequalities, which is what we're going to do today, involves shading the half planes. So we're not only going to have a line going through our graph, we're also going to be shading in part of the graph. Okay. When graphing a linear equation, only the points on the line are solutions. When graphing an inequality, possible solutions, that should have an S on it, may be on, above, or below the line. We shade the regions that apply. We're going to talk through our steps and then we'll apply them to our practice problems. Step 1, transform the inequality so that y is by itself. Kind of like when we graphed lines, we liked it to be y equals mx plus b. It'll be the same kind of thing here, except we won't have an equal sign. We'll have an inequality symbol. Step 2, graph the inequality using the same methods for graphing equations. So like I said, the whole y equals mx plus b thing, using your slope, using your y-intercept. We're going to use the same kind of methods here. Here's where it gets a little different. When we graph our line, we use a solid line if our symbol is less than or equal to or greater than or equal to. So if it has that little equal to bar under it, we use a solid line, kind of like when we did it on the number line, we used a closed circle. Same idea, solid line if it has the equal to bar. We use a dotted line if it doesn't have the equal to bar. Similar to how we used an open circle on the number lines. The last part is shading, which can be the tricky part. We shade below the line if we have a less than symbol, with or without the bar. Less than, we go below the line. Above the line is where we shade if we have a greater than symbol, with or without the bar. Kind of like shading to the left or to the right. Now it's above or below our boundary line. All right, so our first example is y is less than or equal to 2x minus 1. Step 1 is to get y by itself. Is y by itself? Yes, it is. If we were to imagine that this is an equal sign, this looks like y equals mx plus b. So yes, y is already by itself. So then we're going to graph the boundary line using the same method we would use on those warm-ups. Meaning we're going to identify our m and our b. Somebody I have not heard from yet today. Tell me my m and my b. Lexi? Mm-hmm. Wonderful. M is 2, b is negative 1. We're going to graph it just like we did on those warm-ups. So we start at our y-intercept, which is negative 1. So on the y-axis, we put a point at negative 1. Then we use our slope. If we were to write our slope as a fraction, we would put it over 1. So who can tell me where to go next? Natalie? Very good. We can go up to right 1. Up to right 1. We keep doing that. What's my other option? Houston?
Down to the left.
Very good. Instead of going up and to the right, we can go down and to the left. down 2, left 1. Either way, we're on the same line. Now this is when it gets a little bit different from what we've done before. When we go to actually graph the line, we have to pay attention to if we want a solid line or a dotted line. In order to figure that out, we look at the symbol here. If it has the equal to bar, what kind of line do we use? Solid line. If it has the equal to bar, we go ahead and keep it a solid line. If it does not have the equal to bar, that's when we use a dotted line. Again, make it go all the way through the graph. These ones, it's extra important that it goes all the way through the graph because now we have to shade. So our note said that if we have a greater than symbol, we shade above the line. If we have a less than symbol, we shade below the line. Who thinks they know where to shade? Keon? What kind of symbol is this? We would read this as a less than. So we would shade, Natalie? Below the line. So if you need to write yourself a note at the top of these guided notes, that this and this one, these are less than. See how the symbol kind of makes an L? If you kind of look at it with your head tilted, right? This kind of looks like a tilted L, less than L. Okay, the other ones would be greater than. So if it's less than, we shade below the line. Below the line meaning down in this area here. So this whole side below the line gets shaded in. Now that can be a little bit tricky. Sorry, I'm trying to change my color here. So this whole area is getting shaded in. Now it doesn't have to be perfect, but I should be able to tell that that's the side that you're shading in. It doesn't have to be shaded in like dark black. You don't have to use your whole pencil, all your lead to do it. But I should be able to see that that is clearly where you're shading. What I should not see is that you did this. Okay, that is not sufficient. That is why we make our line go all the way through the graph. Also, don't get sloppy. It should not cross over the line. Don't do that. Just, if you want, you can like outline the space that you're going to be shading in. And then just zigzag your pencil through it. I kind of like when I made a big deal about your dots on your number lines, like don't make it obnoxiously large, don't make it so small I can't tell what it is. I'm kind of the same way with shading. All right, our next one is y is greater than -2. Notice that I read this as a greater than. If you need to write yourself a note about what greater than symbols look like, do that. Is y by itself? Yes, it is. So we have to start graphing. Can we identify an M and a B? These ones are a little tricky. Jaquan? Very good. M would be 0 and B is -2. If you forgot how to do that, if you're not sure how we came up with that, the other way of graphing these is to make a table. Okay, when we did these with an equals sign, this said y is always going to be -2. And what happened with x? It could be any number. Okay, so we could pick whatever we wanted to go in the x column. This only works if you only have one variable there. So we can still do it that way here. So like 0, 2, and 4. Either way, whether you use your slope and your y-intercept or you make this little table, you're going to end up with the same line. Okay, our y-intercept is -2. That's the point 0, -2. Okay, if we use our slope as 0 over any number, so it could be 0 over 2, we would rise 0. We don't go up or down, we just go over 2. Or 1, or whatever you want your denominator to be. We are ending up with a horizontal line. I don't care how many points you put on it, it should be a horizontal line straight across. Do we want this line to be solid or dashed or dotted?
Dotted.
A dotted line. How did you know that, Keon? Good. Our inequality symbol does not have an equal to bar. That means it's going to be a dotted line, which I kind of already have a dotted line, but if you don't have as many points as I do, you can kind of just make a little dashed line here. Either way works. If you didn't put dots all the way across like I did, you need to make sure you have a dashed or dotted line that goes all the way across your graph. It needs to be obvious to me that it's dotted. I know that that can be hard sometimes on the graph paper. Okay, but so maybe make your pencil a little darker, make the line a little bit thicker so that I can tell where your line is. Also, making it go all the way through the graph and putting the arrows on the ends will help me figure out where your line is. Helpful hints. The last thing I have to decide is where to shade. Above or below? Natalie? Above. Above. This is a greater than symbol. For greater than symbols, we shade above the line. Notice that I'm shading above the line that I made, above my dotted line. I'm ignoring the axis that was already there. We're going all the way to our dotted line. Let's do this one together as well, and then maybe I'll give you a few minutes to try the other ones on your own. Again, this one is a special situation. So on this one, usually we say, let's get y by itself. Is there a y to get by itself? No, we don't have a y at all. These are the ones that don't have slope-intercept form. So on these ones, I would recommend just going straight to an xy table. Who can tell me which column to fill in right away? I'm going to need some new volunteers, or I'm going to have to get the sticks out. Adrian?
X.
My X column is going to be? Adrian? What is my X column? What does X have to be every time? What did you say at first? I just can't hear you.
4.
Oh, 4. We don't need to put it over 1, but yes, we could if we wanted to. Our X column is going to be 4 the whole way down. Who can tell me what they want in my Y column? Inching closer to the sticks. Ryan? 0 is a good option. What else do you want in there? Sure. Give me one more. -1. Sure. That column can be anything you want it to be. So then we plot those points. 4, 0. We are going to go to the right 4 and then not go up or down. 4, 1, we go to the right 4, go up 1. 4, -1, we go to the right 4, go down 1. If we didn't already know it by looking at the problem, this is going to be a vertical line, straight up and down. So then we have to decide, should this line be solid or dotted? Delaney? I will politely disagree. Deja? Why? Very good. We do not have an equal to bar on our inequality symbol. If there is not an equal to bar, that means our line is going to be dotted or dashed. So our line's going straight through those points. It is a dashed line, dotted line. It goes all the way up and down through our graph. Now this is where it gets a little bit tricky. Because we were talking about before in our notes that we are either going to shade above or below the line. That does not make sense for a vertical line, right? We're not going to go above or below this line. We are going to have to either go to the left or to the right of the line. Makes it a little challenging. Who can tell me what kind of symbol this is? Shannon? Less than. So we have to decide, are we going to shade to the left or to the right? Lexi? Left is what's going to make sense here. Kind of like when we did it on the number line. Less than was to the left, lower numbers. So we are going to shade the left side. Again, we go all the way up to our line, but we don't want to cross it or shade on it. We want it to still be a dashed line. On any of these problems, you can always check yourself by plugging in a point. So if we shaded this whole area over here, we shaded in the origin, which is the point 0, 0. So that means that this should be a solution to this inequality. What is my x coordinate here? 0. So if I plug in 0 for x, I should get a true statement. Is 0 less than 4? It is. So that means that I must have shaded the right space. So you can always check yourself if you're not really sure about where to shade. Here we go. First thing, all of these, we were fortunate enough to have y already by itself. So we can jump right into graphing. Nevaeh, can you identify M and B for me, please?
M equals 2.
And
B equals -2.
very good. M is 2, B is -2. So we always start with B, our y-intercept. I think your axes were already marked for you. Make sure you're doing this part correctly, otherwise the whole rest of the problem will be wrong. Start it at your B. Your y-intercept is -2. So we go down 2 from the origin, we put a point. Keon, where do I go from there? Very good. We use our slope, 2. We can put that 2 over a 1. So we go up 2, right 1, or we could go down 2, left 1. All right, then once we've got some points, we have to decide, should the line through those points be solid or dashed? Jeriel, what do you think? Solid. Very good. We've got that equal to bar. That means we want a solid line through those points, going all the way through our graph. I'm not doing a great job hitting that. There we go. All the way through the graph, solid line. Then our last step is to decide, should we shade above or below the line? When the lines are steep like this, it's a little bit tricky to say which side's above and which side's below. So my recommendation is to put your finger anywhere on the line. It doesn't matter where. If your finger's on your line and you go up, that side is above. If you put it anywhere on the line and you go down, that side is below. Okay, so that's one way to help tell which is above and which is below. On this problem, Logan, should I be shading above or below my line? Below, I would agree with that. This is a less than symbol. For a less than symbol, we shade below the line. So I just kind of, ooh, too far. And get it as close as we can. We don't actually want to cross that line though. Shade in that whole area below. On number 5, y is by itself. So we need to identify M and B. Ryan, what are my M and B?
-1 on 2 for M and y equals 3.
Very good. My y-intercept is 3. My slope is -1/2. We start our graph at 3 on the y-axis. So I put a point there. Delaney, where do I go after that? Using our slope. Down 1 and then if we go down, we already used up our negative, so we would have to go to the right. Okay, so we can either go up 1 and left 2 or down 1, right 2. We just have to use that negative sign 1 time and 1 time only. We can go in both directions. If we want to, we get some points and then we just have to decide, is our line solid or dotted? Deja, what do you think? A dotted line, I would agree. So we are going to, one way of doing it, which I've done before, is to put a solid line in there and then just erase little pieces of it. So if you want to, you can do that. Just like use an eraser to turn it into a dotted line. If you would rather just put a dotted line, that's fine. Either way works for me, as long as your line goes all the way through the graph. Then we decide, are we going to shade above or below? It's a little bit easier to tell above and below in this case. May, what do you think? Above. This is a greater than. Greater than means we shade above. Questions about number 5? We'll keep it going then. Kelby, what are my M and B on number 6? Very good. This one was a little bit tricky because of the way our graph is set up. We still go up 6. On my graph, it's a little bit different than yours. We go up 6, we put our first point for our y-intercept. Then we use our slope 2/3. So normally that means that we would go where, Jamal? Where are we going for our slope? 2/3. We go up 2 to the right 3. Now that works on my graph. That did not work so well on your graph. So instead of going up and to the right, we go, anybody? Down and to the left. So if it's not going to fit on your graph, you have to be able to reverse it. Down 2, left 3. Same line either way. Ellie, do I want a solid or dotted line? Dotted line. We do not have an equal to bar, so it stays dotted. So somehow make sure you get a dotted line in there. Dot, dot, all the way through the graph. All right, last step. Do we shade above or below, Shannon? Below, very good. That is a less than symbol, so we shade below. That is a big area to shade on this one. We shade in that whole thing. Questions on number 6? right, we got one more to get through. Last one. Kion, what are my M and B? M is negative 1/4. B is negative 1. Very good. We start off at our y-intercept, which is negative 1. We go down 1 from the origin. Jakeem, where do I go after that? Using my slope. Down 1 over which way 4? Right 4. We can go down 1, right 4. Or we could go up 1, left 4. 1, 2, 3. There we go. All right. Houston, solid or dotted line? Solid line. That's not perfect, but it'll do. And the last thing, Jaquan, are we shading above or below? Below. Solid line because we have the equal to bar. Shading below because it is a less than. Man, I keep on just hitting just above my line. All right, shaded it in, and we are done.